we're going to talk about conditional probabilities and tree diagrams. For my Statistics 3000 class 2013, this is problem 6, okay, and it is exercise 60 in your book. Notice that they do have randomized values from problem to problem, so these numbers might be different from yours, but the method will be the same. Okay, so they tell us that 73% of the light aircraft that disappear while in flight in a certain country are subsequently discovered. Of the aircraft that are discovered, 69% have an emergency locator, whereas 82% of the aircraft not discovered do not have such a locator. Suppose a light aircraft has disappeared. As I'm reading through, it sounds to me like we're talking about conditional probabilities, and so I'm going to want to draw a tree diagram. And that's the first thing I do as I start drawing. So the first branch is either you're discovered or not discovered. Now you can try and write symbols for this, but I gave up on that a couple years ago. And I discovered, no pun intended, that it is a lot easier for me to do this if I just write it in words. I don't get mixed up. So you're either discovered or not discovered. Now 73% are discovered. So let's write that down. So basically the probability of being discovered is 0.73. Okay. Then at this point, now you have to decide whether they had an emergency locator or did not have an emergency locator. So let's write that as emergency or not emergency. And so whether you're discovered or not discovered, you can either have had an emergency locator or not had one. So this is what my tree diagram looks like. So it says, of the aircraft that are discovered, 69% have an emergency locator. So that means we know they're discovered, so we're here. And then 69% had an emergency locator. So really, we just found the conditional probability. So this is the probability that they had an emergency locator if you already knew that they were discovered. Let's see, and then it says 82% of the aircraft not discovered. So the part we know is that they're not discovered, do not have such a locator. And that is 82%, so 0.82 probability. So again, that's the conditional probability. It's the probability of not having an emergency locator if you know that they were not discovered. Notice that my tree is missing a few blanks. I can fill in each of the rest of these branches using the complement rule. So for example, with this 0.73, the complement of 0.73, so 1 minus 0.73, gives me 0.27. And the complement of 0.69 is 0.31, and the complement of 0.82 is 0.18. So I filled out my entire tree diagram. Now these first two are just your basic probabilities. So this is just the probability of being discovered equals 0.73. Whereas this 0.69, that's really the probability that you have an emergency locator if you already knew that they were discovered. That is the 0.69. Now the first thing I like to do with these tree diagrams once I've drawn them out is I like to find the intersection for each of the branches. Okay, so by that I mean, now let's scoot this over and let's find what is the probability that you are discovered and you had an emergency locator. And how do we find the intersection? We multiply the probabilities. So this would be the probability of E given discovery times the probability of discovery. So basically, all I have to do is multiply all my branches. So 0.73 times 0.69, which gives me 0.5037. And I'm going to do that for each one of these branches. So the next one is the probability of discovery given not E, so they did not have an emergency locator, and we multiply along those branches, so the branches are 0.73 times 0.31, oops, 0.73 times 0.31, which gives me 0.2263. And so notice I'm just multiplying along each of the branches until I have all of the intersection probabilities. I don't know if I'll need them all, but to me it's easier to just kind of do all this in advance, just in case. So then the probability, let's see, of not discovered and emergency locator. So not discovered and emergency locator. Let's see, the probabilities would be 0.27 times 0.18. So 0.27 times 0.18 gives me 0.0486. And finally, the probability of being not discovered and not having an emergency locator would be the 0.27 and 0.82. Which gives me 0.2214. Notice that I now have 4 different probabilities for each of the possible intersections, which could come in handy once I decide to start my problem. So let's see, part A. It wants to know if it has an emergency locator, what is the probability that it will not be discovered? So as I try and write that in probability symbols, so let's see, look at it again. If it had an emergency locator, what's the probability that it is not discovered? So the part that we know is that it had the emergency locator, and we're looking for the probability that it is not discovered. So that is a conditional probability. Now, technically, this is a problem that you should be using Bayes' rule for. But again, I don't like to memorize Bayes' rule. I like to just memorize the basic rules that I have to know and then just try and apply them until I get what I need. So we have a formula for the probability of conditional probabilities. So this would be the probability of not discovered and had an emergency locator divided by the probability of having an emergency locator. And let's see if we have any of those probabilities. So not discovered and emergency locator, that would be my 0.0486. Now this is the hard part. What is the probability of having an emergency locator? As you look back up, we didn't actually have just a plain probability of an emergency locator. So instead what we're going to do is we're going to look at it and say, well, which probabilities correspond to having emergency locators? There's this probability for discovery and emergency, and there's also the probability for not discovery and emergency. And it turns out if we add up all of the intersections for anything that has an emergency in it, that will give me the total probability of having an emergency locator. So we just need to add up each of the intersections that have an emergency locator in them. So that would be 0.5037 plus 0.0486. And if I put that in my calculator, I figure out that it is 0.08799. And that is going to be my final answer for part A. Again, I could have used Bayes' theorem, but to me it's a lot easier to just stick with the formulas that I've already memorized. And formulas I memorize and drawing out the tree diagram just to make everything visual and use some logic. Okay, now part B will be very similar, but let's go ahead and do it. So if it does not have an emergency locator, that is the given part. What is the probability that it will be discovered? So we're looking for the probability that it's discovered if we know that it does not have an emergency locator. So again, the formula for conditional probability says you take the probability of the intersection and divide by the probability of what's given. So again, the probability of discovery and not E, let's see, discovery and not E, that would be this probability right here, 0.2263. And now we need to divide by the probability of not E. Again, that was not given to us. So we're going to go through it and we find every intersection that has a not E in it. So that would be, again, this one and this one. And we just add those two probabilities together. And that will give me the total probability of not having an emergency locator. So that's 0.2263 plus 0.2214, which gives me 0.5054. So that tells me that if we know that they didn't have an emergency locator, the probability of them being discovered is about 50%. Whereas in part A, if we know that they had an emergency locator, then the probability of them not being discovered is only about 8%. So pretty good. And that is a full problem with how to use the tree diagrams to solve this problem.